that process, kind of observing and also developing guidelines around erosion sediment control and stormwater practices, and also done a little bit of evaluation work on polymer use on erosion sediment on construction projects for erosion sediment control. And so the most recent thing, and kind of most of the content that I'll be talking about today is based on my work for the erosion and sediment control guidelines. So that was like a major update to the previous guideline that most people are familiar with from 2006, and it was called the Greater Golden Horseshoe Conservation Authority's Erosion and Sediment Control Guideline for Urban Construction. So we did a major update in 2000, and it was released in 2019, and I led the development of that guideline and released that out in 2019. So that's kind of a lot of what we are touching on here, and I'll talk about what some of the major updates were. First, I wanted to just mention what the Sustainable Technologies Evaluation Program is for those that don't know. So it's a conservation authority initiative. So for now we have 3 conservation authority partners. So it's Toronto Region, Lake Simcoe Region, and Credit Valley. And we work together to achieve our objectives. So we do monitoring evaluations, we do research on primarily stormwater management technologies, low impact development, green infrastructure, erosion and sediment control, and we focus on support, like getting the research and data we need and tackling barriers to broader implementation of these types of technologies that are effective in the Canadian context specifically. Once we kind of understand which technologies are effective, we also develop tools, guidelines, policies that will help kind of the uptake of those technologies. And a lot of the work we do lately especially is focused on professional education, training. We have a conference, annual conference, so that's kind of what STEP's all about. But I'm happy to answer any questions. Also, we have a booth, and if you guys want to talk to me later, I'm happy to answer any questions. So I erased the word new because 2019 is not new, but I don't know if anybody else feels the same way. It's like 2019 to now, it's like a blur, and everything was like different since then, but it's not new. It's just that some people are actually still a lot of times referring to the old guidelines, so to me it's still new. But the guideline that we released in 2019, these are some of the highlights I wanted to touch on because these are things that are kind of were different and significantly different from the previous. So what I'm going to talk about mostly today is risk assessment and mitigating risk. So we did include a qualitative erosion risk assessment methodology for the first time. We tried to clarify the ESC approvals process. We hear a lot about how it's not clear, it's confusing. People have a hard time figuring out what's expected and submissions and everything like that. So we tried to make it easier as best we could. Updated information on best management practices, so all erosion control BMPs, sediment control in-stream, isolation BMPs, and removal of any of those proprietary names. So we removed all that because we wanted to make it generic so that we don't have to constantly update the guideline every time there's a new product on the market. We included updated guidance on in-water isolation. For the first time, we also talked about how to protect low-impact development features. So like if you're putting in rain garden, bioswale, well, how do you protect that during construction when you're maybe like leaving that area aside and continuing your entire subdivision or whatever. With construction, like that's going to get compacted, sediment's going to get in there and clog, which the whole point of it is it's an infiltration practice. So we put in some best practices for low impact development during construction. And lastly, we included kind of like how to assess the effectiveness of your ESCs through monitoring, and we included turbidity targets and some guidance on how to look at turbidity and also the duration of how long something's been elevated turbidity as a way of assessing your actual potential aquatic habitat impact. Okay, so I'm going to talk mostly, as I said, about the risk assessment part and of the guide and kind of go through what that looks like. And then maybe I'm going to talk about kind of some high-risk things on construction sites and how to mitigate erosion and sediment releases during those types of activities. So why is an erosion risk assessment necessary? So, I mean, to me it's obvious, like why wouldn't you do an erosion risk assessment, and how do you do an ESC plan without understanding what your erosion risk is? It's kind of basic to me, but like not basic, but it's like obvious. But what it does really at the end of the day is it demonstrates that helps you to understand what your high-risk areas are on your site and flag them early in the planning process. And decide where, if you're going to spend money or like spend time and energy installing BMPs, where you're going to get the most bang for your buck in terms of mitigating risk. It also provides regulatory agencies with more context for how you develop your ESC plan, and it encourages you to use like better controls, sometimes double of the controls, redundancies in the highest risk areas. I call it a qualitative ESC approach. The qualitative ESC, erosion risk assessment approach we include in the guide. It's basically a hybrid. So there's a document, MTOs, it's called Environmental Guide for Erosion Sediment Control During Construction of Highway Projects 2015. Maybe outdated now, and maybe they've replaced that now, but we used kind of like the assessment they defined there, and kind of hybrid with the revised Universal Soil Loss Equation for application in Canada. And the MTO one is qualitative. The Russell one is actually a calculation that it tells you the exact amount of soil loss you're going to have. We heard feedback early in the process of like developing the guideline that some of that math, like that actual detailed calculations, wouldn't necessarily be a lot of work, but not necessarily for a lot of payoff. So we wanted to develop something that was more manageable in terms of like, in your ESC planning process, some considerations you could take in, but it would be qualitative, not doing like full like Russell equations. So the hybrid approach requires you to do a qualitative assessment based on soil erodibility, topography, and ground cover. And it's done as prior to your ESC planning, prior to starting construction. On larger development sites, you would divide the site into polygons that are of similar erosion potential, and then they assess each polygon. And then the outcome of that assessment would determine what kind of BMPs you would select. And so I'll go through that process here. So step one, you would collect your site information that's related to erosion risk, so soil type, topography. You would then divide your site into polygons defined as areas having similar erosion risk based on your site data collected, GIS, and suitable sizes would range from about 0.5 to 10 hectares. I know that's a big range, but it really depends on your site. And then you would rate your erosion risk for all the factors for each polygon. And so you would use, these are tables provided in the guide. So this is just like mentioning like knowing your soil not just at the grading level, not just topsoil, and understanding the erodibility class. And understanding that the erodibility class is determined by particle size and soil texture, permeability, and structure, organic matter content. So this is just a kind of qualitative grade to tell you like based on what your soil class is, like what you should be rating that polygon as. So from something like the clays, which are not very erodible, all the way to silts that are highly erodible. And again, like that is one part of the equation. So understanding like that's the erodibility, that's how likely it is to leave and be mobilized in stormwater, but also considering clays are not necessarily that erodible, but once they are in suspension, they're going to be really hard to remove, and they don't want to settle up because they're so small. So it's part of the like what you need to look at is erodibility, but also just when you're looking at clays, you don't want to neglect having some sort of erosion control just for that reason, because they are very hard to settle and they would cause a significant amount of turbidity, as you can see based on the fact that they're very fine. Moving on to topography, obviously considering that long and steeply sloping areas are more susceptible to erosion, and they need specific consideration, so you want to identify those areas. So a lot of your polygon delineation is going to be based on topography, because your entire site might have similar soil, so a lot of it is just going to be based on topography. You want to make sure it's preventing erosion on the slope face, using things, stabilization, flow interruption. You may want to divert water that's showing a slope drain that was constructed as part of ASC field training we did several years ago, but slope drains are always an excellent idea to prevent erosion on the face of a slope. And so looking at topography, you would look at your gradient and the erodibility, and it would be those two factors blended together to determine, and then with length to determine what your rating would be. So you go through that exercise as well. Then looking at ground cover. So the site yet to, bare land with nothing on it. So consider like what kind of surface you're talking about, and also considering just, the fact that seeded lands that haven't like been established and don't have significantly don't have significant vegetation just because they've been hydroseeded or whatever, they're not necessarily going to be giving that protection that you need. So just considering all these factors and ranking your cover factor, and then putting them together. There's a table that helps you put them together and understand like, okay, well, what are my rankings in each of these polygons based on what I got in each of your tables. And so once you kind of establish, okay, this area of my site is low, moderate, or high erosion risk, you basically look at best practices that are most appropriate. You prepare your ESC plan based on selecting those practices, and repeat the process for each construction stage that has a distinct ESC plan. So if it's a different stage and you need to make a new plan, you would reconsider erosion risk assessment as well. When it comes to looking at the actual EMPs you'd be selecting, this is also from the guide and kind of gives you an idea of what should be applied depending on the risk you're looking at. So we're saying that procedural ESC measures, that's like good housekeeping, planning your construction, exiting, and things like that, like good housekeeping type practices, mostly non-structural. Having an erosion sediment control plan, these are things that should happen across the board, and also routinely inspecting your erosion sediment controls to see that they're effective. Those are really, no matter what your risk is, you should be doing those things. But when you're looking at higher risk, and you get into things like diverting flows around areas, of course that makes perfect sense if you're thinking, I have a high erosion risk because I have a steep slope, I have very vertical soils, or I have no cover on my soil. Those are the things that are going to flag you as high risk. So you're going to want to do flow or runoff diversion around that area. Phase construction, progressive rehabilitation, that speaks to not stripping or stabilizing as you go. More intensive ESC measures and turbidity monitoring. So more intensive ESC measures, if you are looking at a high risk area, and especially if that area is flowing into potentially a natural feature or receiver, and you have to look at, okay, well, what can I do? Like, I'm diverting flows, I'm going to phase things, but I can also look at more intense measures where there's maybe redundancies, double row silt fence, maybe there's some other interventions that come into play. Maybe there's some sort of water treatment and collection, but if you're actually saying like, well, I have to ensure that I don't release water from this high risk area into the feature, then there's a lot of more like intense things that can be implemented to make sure. And then turbidity monitoring. Again, for the highest risk, we're saying like continuous turbidity monitoring, assuming that's a location that's actually possible to implement something like that. You do have to have like water at all times in some location to be able to do a continuous monitoring. So that's kind of like the approach. Hopefully it wasn't too confusing. I know it's a lot to go through in a short time, but I thought it would be helpful to kind of shift and maybe talk about like something that can not necessarily, it is high risk in the fact that a lot of times these kind of activities do result in sediment discharges from your site. And so I wanted to kind of go through some best practices, because this is another thing we included. We specifically talked about the need for pumping and dewatering protocols, because a lot of times they're not like kind of described on ESC plans or notes, and they really should be, and there should be like a very distinct plan and redundancies and backups and equipment on site in place to be able to execute this kind of work, because it's almost every project requires this. So you want to make sure that you have dewatering protocols and plans in place. That's in place when you are planning dewatering, which means like I'm going to dewater my pond because I'm going to clean it out, or unforeseen, like there was a huge rain event and there's water in places I never hoped it would be, so I got to do dewatering. Also, ESC plans that they should include dewatering protocols, especially if there's activities like sediment pond dewatering, pumping water out of excavated or low-lying areas following a large rain event, using a sump pump to remove groundwater and excavations below the water table, or repair or replacing any underground services. that stuff's gonna happen in your project, or you think it might, definitely should be the protocol in place. And so there's a lot of things you want to consider when you're looking at kind of what your plan would be for how you're going to do this dewatering and water treatment sometimes before you release this water. So you want to look at, well, what's the water movement rate that I'm actually allowed based on your permits. You want to look at the receiving system water quality standards. In Toronto, I think there's a pretty stringent sewer use bylaw, so you actually have to have, I think it's like kind of beyond what we usually even talk about for natural receivers to receive. So I want to say 15 milligrams, but I don't know if it's changed, so don't quote me on that. Also, there's temperature standards for discharge to the natural features, especially cold water fisheries. You have to consider like the water that's receiving and whether you're changing the temperature in a significant way due to how much water you're releasing there. Proximity to groundwater, dewatering. So is the feature within the zone of influence? You want to consider that. How erodible is the discharge location? So are you stabilizing that area where the water's coming out, or are you dissipating the flow in some way so that you don't create like a huge erosion issue? You've gone to all this effort to maybe do some treatment or a sediment bag or whatever you did, but then at the pipe pump outlet, you have an erosion issue that just created more sediment and mobilized more sediment that you never planned on. Also, you may have monitoring requirements for water quantity or quality, depending on what your permit says that can be imposed, and also just contingency planning. Having a backup solution in place, like on site, that can be implemented quickly. Like the equipment should be there. It shouldn't be something that you have to order and wait for, and then you're just in a difficult situation. So just having those supplies on hand and having a plan is really important. I'm just going to go through a couple of these solutions that are typically used that I think are worth talking about. So sediment bags are probably one of the most common you'll see. And what happens is there's energy dissipation and filtration to some extent, especially as it starts to get full. There's a bit of a filtration effect because it's harder and harder for sediment to pass through and it settles out. And the fact that it kind of discharges water all around the bag also is a flow dispersion technique. When you're talking about something like less commonly used for sure, maybe some people in this room, because you guys are experts, have used some stuff with polymers, but there's polymer-based treatment trains, and a lot of times you just put a flocculant. A lot of times it will be a ditch application that's in an existing ditch or a constructed structure, and they'll use flocculants to help settle out the water, and you have to provide a settling area for that sediment somewhere. And it's basically just really quickly expediting the process of settling. Then there's of course fractionation tanks, and they have weirs and sometimes more than weirs, but like different technologies and structures inside of the weirs that will help you just remove floatables and settle out things that are heavier sediments that will settle out. And you have to usually consult with the provider to make sure you're optimizing based on your flow rate that you're going to be pumping through. So you can get the treatment you're hoping for. Because a lot of it is based on like how much time you're providing. If you don't provide enough settling time, like many things just won't settle. So the size speaks to how long it will get to sit in there before it's released again. And then of course the Cadillac, or I don't know if that's a really good reference anymore, Cadillac, but the active treatment systems would be more intensive water treatments. It's basically like you're treating the water almost like, not drinking water because you're not going to chlorinate it, but at that standard really. You'd have, where you have like a small space, you really do have to meet some permit requirements and standards, and nothing's working and you have a lot of fines and nothing's settling out. Also, where you may have certain contaminants of concern that you have to treat, you may want to go to something like an active treatment system, which would incorporate things like fractionation tanks, maybe sand filters, flocculants for sure. People that are better at this than I am will tell you exactly what all those pieces are, but there's like a little example of the system in the bottom corner there with all the different parts, and you're going to get, if it's executed properly, extremely clear water at the end of a system like this. And so moving on, I wanted to talk about another high risk, and everybody would acknowledge it's really high risk, is winter activities. I think I still have good time, right? Five? So for winter construction activities, and especially spring melt, I think, and talked about enough, and I think it's because it's challenging and it's difficult to have the answers. Because we have freeze-thaw events, mild temperatures, sometimes we get rain. I mean, especially I'm in Toronto, we get rain a lot in the winter. Challenges with installing sediment or repairing them when you have frozen conditions is another one of the barriers to like having something that will really provide that protection. Of course, when the ground is frozen, everything's fine, but as soon as there's a melt or rain, that's when you start to see really significant sediment mobilization, and you can see a lot of spills during these times. So looking at like kind of the toolbox of erosion sediment controls you would typically have access to and how they're affected by winter, vegetative ground cover, as we know, can't be established outside of the growing season. For hydro seeding, a lot of stabilizers are ineffective in cold conditions, and there's going to be less growth of seed or none at all. For divergent structures, it can be difficult or impossible to implement on frozen soils. You have to install sediment basins prior to ground freezing. For silt fence, because you're trenched in, you don't want to do that on frozen ground either. I do have an alternative installation that I can show for when you're repairing it, but you probably don't want to be installing brand new silt fence for the first time in the dead of the winter. Erosion blankets can't be installed correctly on frozen ground because you have to prepare the ground, have good ground contact, and you don't want an improper installation to slip away as soon as those high flows and melts start to come through. Grassland swales, again, with the growing and establishing of seed would be difficult, and impervious stabilization, again, even paving and things like that should be completed or can be completed in the winter. So your toolbox is shrinking, and there's all these flow problems and high flows coming through, and so it's kind of like a compound problem. So how do we address some of these things? There are certain solutions you can consider. So ensuring enough capacity in your sediment traps and basins before. All these things have to really be done before. This is the inspection maintenance, and then I'll talk a little bit about like kind of the tools you can use. But inspection maintenance, just looking at capacity, making sure stabilization is completed and is effective, like the stabilization is really well established and secure. Removing and replacing any inlet controls that could end up leading to pond and water and ice, where it would be a safety concern, so clearing some of those areas. Stabilizing your ditches and diversion channels, and reviewing your site, anticipating areas that there could be potential runoff. And you have to think, well, do I need more controls here? This is really where I'm going to get a lot of my runoff coming through, and do I need to beef up this area? So kind of making that overall assessment and consideration. So then when you look at the tools that you do have, you're going to want to prepare a detailed winterization plan that's going to be implemented, and you want to take special consideration to how each one will be maintained, because maybe in the winter people are not there as often, and you want to understand like, well, you will have inspections and maintenance, and how frequently they'll be, and can this be maintained. And in the winter especially, always, but especially in the winter, because some things will fail and be less effective, multiple lines of defense is a solution. That redundancy is always a good solution. So any ESC measures that can be installed should be installed. Silt fences and other practices that require earth disturbing, of course, before the ground's frozen. You want to maintain an adequate buffer width from perimeter controls. You want to have larger access points to provide for snow stockpiling. If you have your snow management plan, you should put your pile locations downstream and not upstream of unstabilized areas, because of course, as soon as that all melts, you're going to take all that sediment. Any drainage structure should be kept open and free of snow and ice dams. You want to limit any exposed areas to those that will be active in the next 15 days, or those that can be mulched in one day how detailed you can put your notes together for winterization. So it's talking about a lot of stabilization schedule things. So it's when the areas should be seeded and mulched, on October 1st if it's stabilized, different details and what seeding ratio you used and different thresholds for when stabilization should occur so that you're going to be ready for the winter. So this is the kind of detail that would be really good to have. That's all. And maybe it is. Contact info. I'm sure you can get it for Rex if you needed it. And this is just a little plug, or a shameless plug for the Source to Stream conference, which registration is open, and we just are releasing our list of speakers, so you can actually look at the program if you're interested and want to know who's going to be speaking. We'll be on the website soon. Thank you so much.
We got a couple minutes for questions. If anybody has questions.